Good morning. This is your Stat Sensei, Mr. Spensei, and this is classwork 2.9, beginning with problem 19. The histogram below displays the times and minutes needed for each freshman in a sample of 26. So if I add up all these values, 6 plus 4 plus 6 plus 1 plus 4 plus 2 plus 2 plus 1, that should add up to 26. It was determined that the largest observation, 93, is an outlier since Q3 plus 1.5 times Q3 minus Q1 is 87.125. So in other words, we could not, anything that exceeded 87.125 was an outlier. 93 is larger, so it is an outlier. Which of the following box plots could represent the information in the histogram? So let's do a little bit of studying here. First off, we know that 93 is an outlier. I'm going to make a dot for 93. The first number that's not an outlier is at 70. So that begins the bar. Okay, and then we're going to have the rest of our box plot. And I'm just going to sketch it out. I really don't know what it's going to look like just yet. Okay, so there's the rest of my box plot, but 70 is the largest value that's not an outlier. Well, real quickly, I can look at these and go, well, 93 they marked as an outlier, which is good, but this says, oh, this is at 87.125, or this looks like this is 87. It's definitely not 70, so this one can't be it. This one can't be it. As I continue on, I go, well, that's a possibility. This one, this is, because that looks like that might be at 70. This one is not at 70, so it can't be that. So we eliminated three just by identifying the highest point that was not an outlier. Okay, let's take a look at the median. All right, so the median is going to be 26 plus 1 divided by 2. So our median is going to be 27 over 2, which is 13.5. So the value that's the 13.5 value or in that bin. So 6 plus 4 is 10. So that's not enough, so it has to be above 20. If I add 6 more to it, so 6 plus 4 is 10. Add 6 more, that's 16. So somewhere in this bin between 20 and 30 is the median. Well, this has the median right here as being below 20 because we know it's going to be somewhere between 20 and 30 is where that median is going to be. Well, turns out this is below, can't be that. When we look at D, D looks like, oh, there's 30. It's definitely between 20 and 30. This is at 70. There's our outlier. We don't need to go any farther than that to determine which one it is. All right, the travel time, the travel miles claimed in weekly expense reports of the sales personnel at a corporation are summarized in the following box plot. All right, so here's our minimum, here's our maximum. Which of the following is the most reasonable conclusion? So in this case, we're looking for a true statement. The median and median numbers are roughly equal. No, it's definitely not. We know the median, but I can look at this and go, you know what? This is skewed. The mean is going to be somewhere to the left of the median. So even though we don't know the mean, it's skewed to the left. So the mean will be to the left of the median. Can't be that. That's a false statement. Most of the claimed numbers of travel miles are in the 0 to 200 range. Okay, so remember, this is the median. This is 50%. Well, 50% is here. Well, that doesn't include that. That's below it. So that's less than 50%. So that's false. Most of the claim numbers of the travel miles, excuse me. I'm sorry. I skipped out with C. B, so C is false. We just answered that. B, the mean in the number of travel miles is greater than the median. No, it's skewed to the left. So the mean is definitely going to be somewhere down here, somewhere lower than the median. The median's here. The mean will be somewhere in this range because it's skewed to the left. Skewed left, mean left. That B is also false. All right. Most of the travel miles are in the 200 to 400, 200 to 240 range. Well, guess what? There's my max. This is 200. This is 50%. So this is over 50%. So yes, over 50%, over 50% would be most. That's true. All right. The left and right whiskers contain the same number of values from the set of personal travel miles. That's tricky. This does contain 25%, but this whole thing contains 25%. So this has four data values over here. So this has less than 25%. If there were no outliers, that would be a true statement. But because there are outliers, from here to here is 25%. All right, moving on to number 21. Professor James gave the same test to the three sections of statistics students. On the 35 question test, the high score was a 32 and the lowest was 15 based on the information displayed in the box plots, which the following statements is true. Section 1 has the smallest interquartile range. No, remember this is Q1, this is Q3, and IQR equals Q3 minus Q1. Section 2 definitely had the smallest. This would definitely be the smallest IQR without doing any calculation. So Section 1 has the smallest. No, that's false. Oh, and we're looking for a true statement. The lowest score in Section 2 is higher than the highest score in either of the other sections. Well, that's the lowest score in Section 2, and definitely Section 3 definitely has values higher. Section 2 has the smallest range of scores. Okay, range, remember, is max minus min. So in this case, our range is probably about 33 to, I don't know, 23. So about 10. In this case, we're looking at about 23 to 17. So 23 minus 17 is 6. So that's false. Section 1 has the smallest range. The top 25% of scores in Section 2 are lower than the highest scores in Section 3. So the top 25%, that's this group right here. And that group right there is definitely higher than the scores in Section 3, so that's false. At least 50% of the scores in Section 3 then are higher than all of the scores in Section 1. Well, 50% is the median. And I look at the median and go, yep, that median is definitely higher than Section 1. That's my true statement. 22, a sociologist collected data from a sample of people on their highest level of education and the number of times they visited any fast food restaurant during the previous week. The data are summarized in the box plots. So we have high school, community college, four-year college, and more than four-year college. Based on the box plots, which of the statements must be true? The number of people served at the four-year college is greater than the number of people at the high school. We have no idea. All right. We have no idea. The box plot doesn't tell us anything about sample size, so that's false. We have no idea. This could have the highest, or this could have the highest. We have no idea which one has the highest. We can't tell that by looking at the box plot. The proportion of people surveyed from the first quartile to the third quartile at the four-year college is less than the respective proportion at the community college. Well, they said first quartile to the third quartile, and they're talking about proportion. Well, guess what? This is 25%, and this is 25%, and this is 25%, and this is 25%. So they all have exactly the same, so that's false. They both have 50%. There's 50% in the IQR. The interquartile range for the number of visits at the more than four-year college level is less than the IQR for the number of visits at the community college. So more than 4-year, this is the IQR. When I look at this, it has a 2 IQR is Q3 minus Q1. So in this case, 2 minus 1 is 1. Over here, I'm looking at an IQR. I'm going to say that's about a 2.5. So it's going to be 2.5 minus 1 is 1.5. So the four-year college has a smaller IQR than the community college. So that's a true statement. So that's going to be my answer. The maximum number of visits at the community college is greater than the maximum number of visits at the high school level. All right. So here's the community college max level. Here's the high school max level. That's a false statement. Community college is not higher, it's lower for the max. The median number of visits at the four-year college, well, the median number at the four-year college is right here at about 2.5, is greater than the median number of visits to high school. Well, the high school level is about 3. So this is about 2.5. This is about 3. The high school is greater, so that's also false. So our best answer for number 22 is C. All right, moving on to number 23. And we're going to talk about interquartile ranges. One thing to keep in mind about interquartile ranges is when we look at this, we're talking about cumulative graphs. Well, this is proportion, and they always increase going up to 100%. It can't go higher than 100%. So it says, what's the IQR? Well, IQR is 25%. So there's Q1, or maybe I should say this, IQR equals Q3 minus Q1. Q1 is 25%, Q3 is 75%. So Q1, and I go, oh, that looks like 1, 2, so 1.8. And up here at 75%, we look like we're about 2.9 or 3. So 3 minus 1.8 is 1.2. So somewhere between 1.1 and 1.2. Our best answer choice is A. That's by far the closest. Okay. Next one. Given the cumulative frequency plot, what can be said about the value of the mean? Okay. This is a tricky question. First off, what's happening is we're increasing a lot. Matter of fact, if we made a number line, we'd start off, our X value started off at 10, and then we went to 80. Well, initially, between 10 and about 15, so I'm going to just sit there and count these out. 20, 30, 40, 50, 60. Looks like I didn't do a very good job of this, but 70. So there are counted out. Most of my values are, I have a lot of values here below 20. Well, that means at 50%, I'm at 20. So this is way up here, and then it declines. So it tells me it's skewed right. So given the cumulative frequency plot, what can be said about the value of the mean? Well, if it's skewed to the right, the median is going to be here somewhere around 20. So the median is going to be about here, 20 to 30. And the mean will be to the right of the median because it's skewed right. If it's skewed right, then the mean is to the right. So we know for sure it's not going to be between 10 and 15. That's where 10 and 15, that's about where Q1 is. Between 15 and 20, no. 20 exactly, that's about where the median is. We know it has to be more than 20 because it's skewed to the right, and the median is about at 20. So in this case, our best answer choice is D. Moving on to 25. The graph below shows cumulative proportions plotted against land values in dollars per acre. What is the median land value? Well, remember, median is the middle 50%. When we put everything lined up. So we just need to find 50%. Well, this is 40%, this is 60%, so 50% is going to be right here. We draw a line, we drop it down, and it looks like we hit about 2,000, and that's answer choice A. So that one wasn't too bad, right? So please remember that the median is the middlemost value. 50% is larger, 50% is smaller, so it's the 50% value. Number 26, given the cumulative plot above and using the most commonly accepted definition of outliers, what would be considered an outlier? Well, remember, to be an outlier, we have to know our IQR, and Q3 minus Q1 is our outlier. It gives us our IQR. And to be an outlier, X has to be less than Q1 minus 1.5 IQR, or X has to be greater than Q3 plus 1.5 IQR. So let's figure out our IQR. Okay, now, unfortunately right here, this isn't mapped this out really well, but we know this is 100%. So this right here is 50%. So this is 75%. And this is 25%. So 25%, that's Q1, 40. 75%, that's Q3, that's 50. So our IQR in this case is 50 minus 40, which equals 10. All right, so we now know our IQR, so I'm going to go ahead and drop that in both these places. And we know this is going to be 1.5 and this is 1.5. So for our first one, 40 minus 1.5 times 10. So using a calculator, 40 minus 1.5 parenthesis 10, and we get 25. So X has to be less than 25 to be an outlier. So do we have outliers down here? Yeah, anything between 20 and 25 would be an outlier. And on the high side, we have Q3, which is at 50. So 50 plus 1.5 times 10. And that gives us 65. So X has to be greater than 65. We don't get to 65. So there's no outliers on the high side, but on the low side, anything between 25 and 20, anything from this area right here and down. So our outlier had to be greater than 65, not greater than 65, between 20 and 25. That's our outlier. Okay, number 27. The graph below shows the cumulative proportions plotted against the number of employees working in a mid-sized retail establishment. What is the approximate IQR? Once again, IQR equals Q3 minus Q1. Remember, this is at 75% and this is at 25%. So when we go there, we're going to go, well, that's 30 right about there. So 25 is kind of right about here, approximately. Drop down. And let's just say, oh, maybe 55. So Q1 might be about 55. It's not going to be exact. Then 60, 70. So 70 is about here. So 75 is about there. And we're doing the best we can. We drop down and it's like, oh, that looks like about 75. So 75 minus 55 gives me 20. Okay? So with that said, 18 is the closest, 35 isn't that close at all. So our best answer choice is A. All right, moving on to the last problem. The graph below shows cumulative proportions plotted against GPA for high school seniors. What is the approximate IQR? Hopefully by now we get the idea that IQR and outliers are really important. So IQR is Q3 minus Q1. Please remember that's 75% minus 25%. So that tells you that this is the middle 50% of the data. So if I sit there and go, well, this is 20, this is 40, 30, somewhere here. So I'm going to guess 25 is about here. And we said Q1 is about 1.9. All right. So this is 60, this is 80, 70 is about here. So 75, somewhere in between. And again, I'm getting as close as I can. And maybe 2.9, 2.8 is what we wrote, so we'll use 2.8. 2.8 minus 1.9 equals 0.9. So my IQR is about 0.9, and I'm going to put a little approximately sign because it's not exactly. So the one that we have that's the closest is 0.85. Obviously, it's not as high as 2. This is by far the closest. So A is our best answer choice. All right. This concludes this assignment. Appreciate you watching. Look forward to seeing you on the next one. Thank you.